Hello friends, welcome to the presentation on Centroid. Myself Prakash Kadve, Principal KK Wak Polytechnic Nasik. In this slide you are getting three diagrams. The first one is rectangle. We'll be talking on centroid, how to find out centroid of all these diagrams. First let me define what is centroid. Centroid is a geometrical center of any of the diagram, which is a two-dimensional diagram. All these figures here have two dimensions, either length width or length height. The first diagram is rectangle. Here this rectangle has got a length L and has got a width B. Its geometrical center, you can say, if you draw both the diagonals where the diagonal intersect each other, that point is called it as the geometrical center of this figure, and that point itself is the centroid of this figure. So if L is the length, it comes at the center, that means at a distance L by 2. And if B is the width, again it comes at the center of the width, that is B by 2 from bottom or B by 2 from top. So that way this point lies at L by 2 from y-axis and B by 2 from x-axis. So this point is called as centroid of the diagram. Here if it is a triangle, in this triangle this side and this side they are equal, that is it is isosceles triangle. This point is the centroid of the triangle where this centroid lies. From y-axis it will lie at width divided by 2. Why it is so? Because if you draw a center line from the apex, you can see there is a symmetry on both the sides. So symmetry means the centroid will lie at the center of that length. So here B is the length of the base, it will lie at the B by 2, but from bottom along y-axis it will lie at h by 3, where h is height of the triangle, and always height of the triangle is the perpendicular distance from the base to the apex of the triangle. Next diagram is right angle triangle. In right angle triangle, this side is called as height of triangle and this side is called as base of triangle. So I am noting it as B and the notation given here for the height is h. This is the point of centroid. As you have seen here, along height it will be at h by 3. So similarly, here it will be b by 3 from y-axis and here it will be h by 3 from x-axis. Because here you cannot get a symmetry of the triangle, therefore it won't lie at the center along length or along width. It lies at b by 3 from the base and h by 3 from the base and b by 3 from the height. This is right angle. So from these two sides it will be at 1/3 of its length. Now this figure is trapezium. For trapezium, this side I am denoting as A, this side I am denoting as B. These two are parallel to each other. So the perpendicular distance between these two is called as h, that is nothing but height of the trapezium. Again, if you draw a center line from this, you will get centroid will lie at the center of the base, that is B by 2. So centroidal axis will be at B by 2 from extreme left hand, but along y-axis it will lie at a distance b plus 2a divided by b plus a, the whole multiplied by h by 3, and this point is called as centroid. Next diagram is semicircle. In semicircle, this is the base, nothing but diameter of the circle. Half of it is d by 2, that is nothing but radius. So this is also radius and this distance is also radius. Along x-axis it will be at d by 2, the centroid will be at d by 2 along this line, but in y direction it will be this much distance, and that distance is 4r divided by 3 pi. So here you have to remember, for semicircle, from the base it lies at 4r by 3 pi in perpendicular direction. Now this is T section, like English capital letter T. So it is a composite section. You have to determine centroid of this. So you cannot directly say it will lie at half and so and so. So here you have to divide this T section into two simple figures. So here I can join a horizontal line, and from this line I am getting this as the first rectangle and then this as the second rectangle. So this second rectangle is called as flange of the section and first rectangle is called as wave of the section. So here I have shown all the notations. Before seeing the details, let us see what equation we'll be using. So x bar is nothing but the centroid along x-axis is equal to a1x1 plus a2x2, the whole divided by a1 plus a2. And y bar, it is the distance of centroid from x-axis in vertical direction. So y bar is equal to a1y1 plus a2y2 divided by a1 plus a2. What is a1 and a2? a1 is area of first figure. So this rectangle I am calling it as first rectangle. It is area of first figure. a2 is area of second figure. This horizontal rectangle I am calling it as second figure. So quite simple area. If length of this is 500 and if width is 200, you can say 500 by 20. So not 200, it is 20. 500 by 20 is the area of first figure. Second figure, having width of 400 and having depth of 20. So A2 will be equals to 400 multiplied by 20. X1, distance of center of first figure from y-axis. So center of first figure, if I draw a center line from this, both the centroid will lie on the same line. So this x1 will be equal to 200 mm, that is half of the 400 mm. Similarly, x2 will also be equals to half of, because it is a rectangle and centroid of the rectangle is at center. So 400 by 2, that is 200 mm is the centroid. Next, y1. y1 is centroid of the first rectangle from x-axis. So if 500 mm is the total height, it will lie at 500 mm by 2. So that is 250 mm from the base. So this distance is 250 mm. Y2 is centroid of first rectangle measured from x-axis. So right from here. So if 500 is the height up to here, then remaining distance, if 20 is the total width, the centroid will lie at half, means 10 from bottom, 10 from top. So you can add 500 plus 10, that is 500 at 10 is the y2 value. Put all these values in the equation, you will get x bar is equal to 200 mm and y bar is equal to 365. So on this line joining this point and this point, somewhere here the centroid will lie. Let us say it lies here. So its y coordinate measured from the base is 365.56 mm. This is the next diagram. This is a combination of rectangle and a triangle. A triangle is placed over the rectangle. Base of rectangle and triangle is same, 30 centimeter and 30 centimeter. Again, this is isosceles triangle. Height of this triangle is given as 40 and height of this rectangle is given as 60. So again it is x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2, and y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. So let us say a1. Again I am calling this rectangle as first figure triangle as second figure. So area of rectangle is height of rectangle multiplied by width of rectangle. So it is 60 multiplied by 30. So it is 60 multiplied by 30. Second, since it is a triangle, area is 1 half base into height. So base is 30 centimeter, height is 40 centimeter. So put it 1 half base into height. 1 half 30 into 40. You'll get answer. Then x1. Now here again x1 is nothing but center of this rectangle along x-axis. So this is x-axis direction. So if total width is 300, since it is rectangle, it will be at the center. So 30 divided by 2, it will be 15 centimeter. Similarly, since this is isosceles triangle, it will be at the center. So 30 divided by 2 is 15. So x1 is 15 and x2 is also 15. y1. It is the distance measured from the x-axis to the center of the diagram along y direction. So here total height is 30. It will lie at 60 by 3. So y1 is 60 by 2, that is 30. Then y2 is the distance of centroid of this triangle, but it is measured from x-axis. So from x-axis this is already 60 centimeter, 60 plus centroid of this. So centroid of triangle lies at h by 3. So 60 plus 40 by 3. This distance is 40 by 3 and this is 60. So 60 plus 40 by 3, you get 73.33 centimeters. Again you can put these values in the equation and you get an answer. X bar is equal to 15 centimeter and y bar is equal to 40.83 centimeter. Thank you.